Hi there. Welcome to part two. Here I'm going to actually model working through that workflow for analyzing data. Number one, define the question. Number two, show the data and do the exercise where you actually draw out what your data will look like if your hypothesis is supported and what it will look like if your hypothesis is not supported. Um, Evaluate your conclusions and confidence, step number three, and then step number four, communicate the evidence. So with that, I'm going to go ahead and model this with a data set from the resource library. All of the data sets that I gave you as options, those 6 data sets that are in the part 1 video, those can all be found in the resource library. So I'm going to come up here where it says resource library. I'm going to click that and go to the resource library. A note about searching for data sets in the resource library. If you're not finding what you're looking for, make sure that you have this title field is clear, because this is going to be a text search. But if you had something in from a previous session, it will keep it in there and it will limit the options that are showing. Also, the grade level search, I've got it set to filter to college level data sets. But if you're searching for something and it's just not coming up, it might be, that a data set that we've set as appropriate for 11th or 12th graders as well. So that's there. Just know those things. So I'm going to go and I'm going to do this data set that's called the Taylor Swift effect. It was there in the front row, but I just searched it to model searching for something by text. And I'm going to go ahead and I'm going to click open the data set right there, that button. Okay, so I'm going to open this data set. Now, these data sets, all the 6 that I've given you as options today, those can be found here in the resource library, and then the assignment is found here on the assignment tab. And I'm going to pop this open as a separate tab. Start my webcam again. Sorry, I made it go away there. This is the student facing assignment. I don't necessarily want you to go through these assignments. You can, if you feel like you don't have enough guidance to go through this data set and it's not, you're feeling a little lost, by all means, go through and you can just work through this activity, as it is written out here, answer question 1, answer question 2, answer question 3. By all means, do that. However, what I want you to give a try is read through the background and take a look at the data set, and then you define what you think the central question is. So a little bit more open-ended of a task, but define what you think the central question is. And that's what we're going to work to analyze. Now, all of the pre-made activities will essentially have you doing that, but they'll be giving you a little bit more hand-holding on what the central questions are. This data set, I'm gonna kind of give you the central background again. We touched on this last week, but I'm just going to review it. Maybe we have some new people with us. So in much has been made this year in the popular press. If you somehow haven't heard of this, I'll give you a little recap, but I suspect you've heard of this over and over again. Pop star Taylor Swift has been dating star tight end Travis Kelce, who plays for the Kansas City Chiefs. Partway through the season, she started attending games when she wasn't out on tour. And much has been made about the economic effect that she has. People estimated that she gave an economic bump of about $330 million in brand value to the Kansas City Chiefs. But what this data set is all about is, okay, we know she affected things economically, but did Taylor Swift attending Chiefs games actually affect the performance of her boyfriend, Travis Kelce, and the performance of the Kansas City Chiefs as a team? Did she have any kind of positive or really negative effect on the team? Was there an effect? So that is the essential question. Now, if I go back over to the data itself and I look at the variables here, we have things like which week number was the game. And if I go over to the table, I can see that, the structure of this data is such that there are Each row in the data set was one of the 20 football games that the Chiefs played prior to the Super Bowl. I can see who their opponent was. I can see were they playing at home or away? Did they win or lose the game? How many points did they score? How many points did their opponent score? The important variable of was Taylor Swift at the game? And this is a categorical variable with the values of yes or no. How many receptions did she have? Did Travis Kelce have? How many times did he catch the ball? If you're not a football fan, that's what a reception is. How many times was the ball thrown to him? That's how many receiving targets. How many yards did he gain in successful catches? That's the receiving yards. What was the average number of yards per reception? Yards per catch, that's what that is. Did he score a touchdown? Yes or no? Kelce touchdown. What was his longest catch or longest reception? And then how many yards of offense in total did the Kansas City Chiefs have? KC total yards. That's, their total yards of offense. So these are all, what we have in this data set is we have, largely we have measures of performance and then a key variable of was Taylor Swift at the game. So if I'm keying in on my key question here is, did Taylor Swift affect the performance of the Kansas City Chiefs? I'm going to have a graph, or I'm thinking about what my graphs look like. I'm going to try to show you here and see if this works. So if my hypothesis is not supported, this is what I sketched out, right? So on the x-axis, I have, was Taylor there? Yes or no? And then on the y, I have some measure of performance that's numeric. And here I kind of sketched out little dots and error bars showing, where the average is and some measure of error. But basically, if my hypothesis is not supported or if Taylor did not affect performance, we expect those averages to be about the same for both groups. I apologize for the low-tech visual aid here. Then I sketched again, and, this measure of performance, was Taylor there? Now we see the average for yes is above the average for no. It doesn't mean every single game had a higher value for yes, but in general, there's more yeses than nos. The average is up. This is what it might look like if my hypothesis is supported. Similarly, if I took a binary outcome, like maybe just what did the Chiefs win or lose when Taylor Swift was present at the game? And here I've done a categorical bubble where the size of those circles is scaled to the count in each of those outcomes that's defined by the combination of my two variables, right? So I have, was Taylor there, yes or no? And I have outcome, win or loss. And we can see that all four of those circles are roughly the same size, indicating that the proportion of wins and losses was not affected by the was Taylor there, yes or no, right? And then similarly, if I look at this visual, outcome, win or loss, was Taylor there, yes or no? I see I have one small circle there in the outcome of loss, and was Taylor there, yes, indicating that, they didn't lose as much when she was there, or they won more often. The proportion of wins to losses was greater when Taylor was there. That would support it. But without looking at the data, I was able to sketch those. And this is not going to be easy necessarily for all of you, but this is a valuable exercise to struggle through making those hand sketches and really thinking about this. And now when I go to graph, right, let's take a measure of performance. Let's take a measure of team performance, like KC total yards. And again, this is Kansas City total yards of offense. I'm going to plot that with show, and we can see, okay, and we'll look at the values as well. We can see the average 353 yards of offense per game. And now if we look for that was Taylor Swift at the game variable, I'm going to add that right here. And we can see that when Taylor was at the game, the average number of yards was 375.7. When she was not at the game, and I'm looking down here, the average was 319.1. So their offense performed a little bit better in the games she was there. Now, this doesn't necessarily indicate that this was causative. There's as a researcher, there's a lot more we would want from an experiment, but this is the data we have. So in looking at the data, it looks like they performed a little bit better. Looking at the 95% confidence intervals, they do overlap. So this isn't necessarily a super high degree of confidence, but I have to say this result did surprise me a little bit. I might choose to run a statistical test here. I'm going to run the graph-driven test. We're going to look at the t-test. And again, this is a test we're testing for a difference in the average between two groups. I'm going to click calculate. And we get a p-value of 0.03, meaning strong confidence the groups are different, or more numerically to think about roughly a 3% chance of getting data that has a difference in means like this with this kind of spread around the data due to random chance alone. So this is somewhat surprising to me that this evidence looks sort of decently strong. Now, the biggest criticism here is we have a really small sample size. We just have 20 games worth of data. There's obviously a whole lot more that's probably affecting the Kansas City offense production, more than just whether Taylor Swift was in the stands or not. But, based on the data we have here, if I was the owner of the Kansas City Chiefs, I would definitely want Taylor Swift to be present at the games. That's about where I'll leave that conclusion. Just to look at another example where, something that has a different kind of outcome, a categorical outcome. If we look at like wins and losses. So I'm going to put that over here and switch, put wins and losses on Y. So I'm just switching over here, checking this and putting wins and losses. And, we can see this graph. And, once again, this looks probably somewhat more like my sketch of data of, supporting the hypothesis that Taylor Swift was affecting the wins and losses, where 9 wins when she was present to 3 losses when she was present versus 5 wins and 3 losses. If you want to dissect this data, you can also say, later in the season, she was at more games, maybe the Chiefs were just improving. That is completely plausible. But, again, here's what the data are. If my central question that I wanted to use data to address was, was Taylor Swift affecting outcomes? This would be a graph I could use to communicate that. And then again, I would probably choose those two graphs in tandem and say, hey, together, this is the story. Judging by the data we have, it looks like the Chiefs performed better when Taylor was at the game. And here's my 2 pieces of evidence. And I would present both of those graphs. So that's sort of modeling that process. For this week, I would like you to go ahead and choose 2 of these 6 data sets, define the central question, think about what the data looks like before you plot it digitally, like actually sketch it out by hand, then plot the data, then evaluate your conclusion, think about how confident you are in that conclusion, and then also think about how you're going to communicate that result with graphs, statements, or tables, and think about how you're going to communicate that data. If you have any questions as you're working this week, you can reach me at aaron@dataclassroom.com. I hope you have a wonderful week, and I will see you in person the following Tuesday, next Tuesday. So have a great week. Don't hesitate to email me your questions, and I'll see you in a week.